June 1943, the island of Bougainville, Solomon Islands. A rust-colored dawn breaks across the jungle canopy, and the sound of American aircraft engines still echoes faintly in the distance. Somewhere in the dense green sprawl of the island's interior, a single Vought F4U Corsair fighter has crash-landed intact. No German observers watch this moment. No Japanese generals stand in anticipation. Yet what unfolds in the hours and days that follow will shake the very foundations of Japanese aeronautical confidence and set in motion a cascade of decisions that would shape the war in the Pacific. For nearly 4 years, Japanese aviation engineers had inhabited a peculiar world of assumption and certainty. Since 1937, the Mitsubishi Zero had dominated every theater where it appeared. Japanese pilots spoke of the Zero with reverence bordering on the spiritual, a machine that could turn inside the radius of any American fighter, climb higher, stay aloft longer, and dance through the sky with the grace of an opponent possessed of supernatural knowledge. That mythology had proven so durable, so thoroughly reinforced by early combat victories, that Japanese military leadership had grown accustomed to framing their air superiority not as a temporary advantage, but as an eternal condition. It was, they believed, the natural order of things. American aircraft were heavier, bulkier, less elegant. American pilots were undisciplined, trained in formation, flying, but lacking the spiritual fortitude that Japanese warrior culture demanded. The gap, Japanese strategists insisted, could never be closed. But the American F4U Corsair that came to rest on Bougainville represented something Japanese engineers had neither anticipated nor truly understood. It was not merely another fighter. It was the material embodiment of an entirely different philosophy of warfare, backed by an entirely different approach to industrial and human organization. And when Japanese technical officers first examined it, setting aside their preconceptions and looking at what was actually in front of them, they encountered not just a new aircraft, but evidence of a way of thinking so foreign to their own that many struggled to process it. The capture itself occurred amid the chaos and deterioration of Japanese positions in the Solomon Islands campaign. Throughout 1943, American forces had pressed relentlessly up the island chain. The numerical tide had turned unmistakably in America's favor. By June, Japanese commanders knew that every island, every airfield, every piece of territory represented a temporary foothold that could vanish in a single engagement. The Corsair arrived in this context of deteriorating positions and shrinking options. A Marine pilot had flown it into combat, encountered mechanical or battle damage, and ditched the aircraft on the island, rather than attempt the long flight back to American-held territory. What might have been a routine loss, one more American aircraft, added to the mounting casualty figures, became something far more significant when Japanese forces discovered the machine essentially intact, fuselage unbroken, systems accessible, the revolutionary technology inside preserved like an artifact waiting to be deciphered. Japanese aviation officers who examined the Corsair first noticed what American pilots had already come to understand. This was not a refined or elegant machine. Compared to the Zero, it appeared almost brutish. The fuselage was substantially thicker. The wing design was distinctly different, not the delicate, beautifully curved forms of the Zero, but rather a more angular, purposeful geometry. The inverted gull wing configuration, which American designers had chosen to allow for shorter landing gear, gave the Corsair an odd, almost aggressive appearance. Some Japanese observers noted that it looked like a machine designed by engineers who had little regard for traditional aesthetics, who cared nothing for beauty or harmony in form, who were concerned only with function, with power, with what the machine could do rather than how it appeared. Yet as they moved beyond first impressions and began the systematic technical examination, Japanese engineers started to encounter evidence of a completely different approach to aircraft design. The Pratt and Whitney R2800 double wasp engine that powered the Corsair represented manufacturing and design philosophy that most Japanese engineers had never encountered at such an advanced level. It was a massive engine, 18 cylinders, 2,800 cubic inches of displacement, capable of producing 2,000 horsepower in its combat rating. But more remarkable than its power was what that power represented: the ability of American industry to design and manufacture complex engines at scale with tight tolerances and consistent quality, such that thousands of these machines could be produced reliably and mounted in aircraft with confidence that they would perform as designed. The Japanese had nothing equivalent. The Mitsubishi Sakai engine that powered the Zero was sophisticated in its way, but it operated at a lower power ceiling and represented a fundamentally different approach to engineering. Japanese designers, working within constraints of material availability and manufacturing capability, had chosen to optimize for weight and maneuverability. They had engineered a machine that was as light as possible, trading armor protection and fuel capacity for agility and climbing ability. It was a brilliant solution to a particular set of constraints. But those constraints were constraints nonetheless, and they marked the limit of what Japanese aviation could achieve within the existing framework of Japanese industrial capacity. The Corsair represented not just a more powerful engine, but evidence of something far more unsettling: access to resources and manufacturing infrastructure on a scale that Japanese planners were only beginning to comprehend. The internal systems of the Corsair told stories in their own language. The electrical systems were robust and redundant. The hydraulic systems were sophisticated and duplicated, with backup systems for critical functions. The fuel capacity was enormous. The Corsair could carry 237 gallons of fuel internally, plus another 165 gallons in drop tanks. To Japanese engineers who had designed the Zero to minimize weight, this abundance of fuel represented something almost incomprehensible. Why would you design an aircraft this way? Why carry so much fuel if it meant accepting additional weight, if it meant sacrificing some degree of maneuverability? Unless you were thinking about the problem in fundamentally different terms. Unless range and staying power mattered more to you than climbing ability. Unless you were planning for sustained campaigns across vast distances, not brief, intense engagements over familiar territory. The armor plating told another story. The Corsair's pilot was protected by substantial armor, 3 8-inch steel behind the pilot's seat, 1 2-inch steel under the pilot's seat, and 1 4-inch steel in the headrest. The fuel tanks were self-sealing. The aircraft was designed with the explicit assumption that it would take hits, that it would be fired upon, that the pilot and vital systems needed to survive battle damage. This philosophy was almost inverse to the Zero's design logic. The Zero was designed to avoid being hit through superior maneuverability. The Corsair was designed to survive being hit through armor and redundancy. Japanese pilots who had encountered the Corsair in combat had reported a disturbing pattern. The aircraft seemed to absorb punishment that would have destroyed a Zero. Bullets that tore through the thin aluminum skin of the Japanese fighter seemed to simply lodge in the Corsair's thicker fuselage. The Corsair could take hits and fly away. The Zero could not. This had profound implications for pilot survival rates and for the sustainability of air campaigns. And as Japanese engineers examined the Corsair, they began to understand that this difference was not accidental. It was the product of deliberate engineering choices reflecting a different calculus about what mattered in air warfare. The instrumentation panel revealed yet another layer of American design philosophy. The instruments were numerous and comprehensive. There were redundant altitude indicators, multiple temperature and pressure gauges for the engine systems, comprehensive fuel management instrumentation. Everything was clearly labeled, accessible, designed with the assumption that the pilot needed extensive information about the machine's status at all times. Some Japanese observers noted that it seemed excessive. Surely a pilot did not need this much information. But the philosophy behind it was unambiguous. The American approach assumed that a well-informed pilot, with detailed information about engine parameters and fuel status, could operate the aircraft more effectively, could manage complex systems with greater precision, could make tactical decisions based on complete understanding of the machine's current state. The Pratt & Whitney R2800 engine itself, now subject to detailed examination, revealed engineering practices that had no real parallel in Japanese manufacturing. Every component displayed tight tolerances and consistent quality. The cylinders were precisely engineered. The valve systems were sophisticated and reliable. The cooling system was comprehensive and effective. What struck Japanese engineers most forcefully was not any single innovative feature, but rather the overall quality of execution, the sense that this engine had been designed by engineers who had access to manufacturing infrastructure capable of holding tolerances that Japanese industry could only approximate. This was not a cleverer design. It was a better-made design, produced within a framework of industrial capability that simply exceeded what was available to Japanese manufacturers. The landing gear mechanism displayed a similar philosophy, robust, substantial, designed to absorb the stresses of repeated carrier landings. Japanese aircraft landing gear, by contrast, was often delicate, sometimes requiring careful landing procedures to avoid damage. The Corsair's gear conveyed an almost casual attitude toward punishment. You could land this aircraft roughly. It would endure. As these Japanese engineers moved through the dissection of the captured Corsair, as they examined each system and began documenting what they found, a growing sense of unease began to permeate Japanese aviation command. This was not simply a more powerful aircraft. This was evidence of a fundamentally different approach to the entire problem of aircraft design and manufacturing. The Corsair was not the product of superior innovation in any single area. Rather, it was the product of abundant resources, sophisticated manufacturing infrastructure, and a design philosophy that accepted weight and complexity in exchange for reliability, survivability, and sustained performance. The Japanese had imagined that superior pilot training, superior warrior spirit, and superior aeronautical design could overcome American material advantages. The assumption had been that discipline, courage, and tradition could compensate for whatever numerical disadvantage the Japanese faced. But the Corsair suggested something deeply troubling, that American advantages were not merely numerical, but systemic. They reflected not the superiority of any single component, but the superiority of an entire system of industrial organization and resource allocation. What was most disturbing to Japanese military planners was what the Corsair implied about American industrial capacity and American strategic intent. If Americans could produce aircraft of this sophistication and capability at sufficient scale to lose them in combat, to simply abandon a fighter of this quality on an island when it was damaged, what did that suggest about the total scale of American production? If a single damaged aircraft represented such advanced technology and such comprehensive capability, what did that mean for the trajectory of the war? Japanese industrial planners had believed throughout the conflict that they could maintain parity with American production through superior efficiency and through leveraging the resources of their conquered territories. The Corsair challenged this assumption. The sophistication of the aircraft suggested that American design teams were operating at a level of complexity and capability that required specific institutional knowledge, specific design practices, and specific manufacturing infrastructure. These could not be simply replicated through will or through access to raw materials. They had to be the product of an entire industrial ecosystem. Moreover, the Corsair's design emphasized not cutting-edge innovation in any single area, but rather comprehensive competence across all areas. American engineers seemed to ask not what is the minimum required to achieve an objective, but rather what approach will provide the most consistent, most reliable, most sustainable path to achieving the objective regardless of the cost. This was a fundamentally different design philosophy, and it reflected different assumptions about the war and how it would be won. The specifications that emerged from Japanese technical analysis of the Corsair told the story plainly. Maximum speed of approximately 400 miles per hour compared to the Zero's 340. Service ceiling of about 40,000 feet compared to the Zero's 35,000 feet. Rate of climb of about 2,530 feet per minute compared to the Zero's similar rate, though the Corsair achieved this from a heavier starting point. Armament of 6 50 caliber machine guns compared to the Zero's 2 20mm cannons and 2 machine guns. The Corsair was faster, climbed strongly, carried more ammunition, had greater range, and could absorb damage that would cripple a Zero. What tactical conclusions emerged from this analysis? The answer was deeply troubling. In a dogfight at high altitude, if the engagement began with the Corsair having altitude advantage, the Zero had lost the advantage that had defined its combat performance since the war began. The Zero's superiority had always been predicated on fighting in its preferred environment, the tight turning fight at low to medium altitude where its lightweight and superior maneuverability could be exploited. The Corsair, with its superior speed, climbing ability, and fuel reserves, could dictate the terms of engagement in a way that the Zero could not. Furthermore, the Corsair's superior armor and self-sealing tanks meant that American pilots could sustain higher casualty rates and still maintain effective combat performance. An American pilot shot down and captured might eventually return to combat duty if rescued. A Japanese pilot shot down had no such option. He was effectively removed from combat permanently. When combined with American production capacity that could replace lost aircraft far more quickly than Japanese industry could manufacture replacements, the implications were stark. The American advantage in air warfare was not going to diminish over time. It was going to expand. Japanese Aviation Command commissioned detailed comparative studies of the Corsair and the Zero. These documents, now preserved in Japanese military archives, reveal the gradual and painful recognition among Japanese engineers that the war in the air was being decided not by superior tactics or superior warrior spirit, but by material advantages that Japanese industry would never be able to overcome. The studies noted that any new Japanese fighter would need to match or exceed the Corsair's performance in speed, climb rate, and altitude capability. This meant larger, heavier aircraft, which in turn meant larger, more powerful engines that Japanese industry was not equipped to design or manufacture at the required scale. The cultural shock of this realization cannot be overstated. Japanese military ideology, forged in the warrior traditions of the samurai and refined through the experiences of campaigns in China, had deeply internalized the belief that superior morale, training, and spiritual commitment could overcome material disadvantages. The Corsair suggested that material advantages could be so overwhelming that no amount of spiritual commitment or warrior courage could compensate. It suggested that the war was not going to be decided by brave pilots and superior tactics, but by factories and production lines and industrial organization. Furthermore, the Corsair represented not just superior American capability in aviation, but evidence of a broader American advantage in industrial mobilization and resource allocation. If Americans could design and build aircraft of this sophistication, what else were they producing? What other weapon systems, what other technologies, what other material advantages were American industry creating? The examination of the Corsair forced Japanese planners to confront a strategic reality they had been reluctant to acknowledge. Japan was engaged not in a struggle for military superiority, but in an increasingly asymmetrical competition with an opponent whose industrial capacity and resource base were simply larger and more comprehensive. The American abundance evident in every aspect of the Corsair's design became almost symbolic in Japanese strategic discussions. Here was an aircraft designed without constraint, designed with the luxury of excess horsepower, excess armor, excess fuel capacity, excess redundancy. American engineers could afford to make conservative design choices because they were not forced to optimize every ounce of weight or every aspect of performance. They could prioritize reliability and survivability over ultimate performance, and they could still produce an aircraft that was superior to anything Japanese industry could manufacture. In the months following the technical examination of the captured Corsair, Japanese aviation engineers attempted to design a successor to the Zero that could compete with American fighters. The result was the Mitsubishi J2M Raiden, a heavier, more powerful fighter that attempted to match the performance of American aircraft. But the J2M was produced in limited numbers, and many of the later model examples suffered from reliability problems and manufacturing defects that stemmed from the deteriorating capacity of Japanese industry. The fundamental problem could not be solved through better design. It could only be solved through access to industrial capacity and resources that Japan simply did not possess. The Corsair's engine, the Pratt and Whitney R2800, became a symbol of American industrial power. Japanese planners understood that the double wasp represented thousands of hours of engineering development, that it embodied manufacturing practices that could only be maintained within an industrial infrastructure of enormous scale and sophistication. The engine's reliability and consistent performance across thousands of examples produced meant that American industry had achieved a level of standardization and quality control that Japanese manufacturers could only approximate. This was not innovation. This was competence at a scale that Japan could not match. As the war progressed and American forces moved closer to the Japanese home islands, the lessons learned from the captured Corsair influenced Japanese strategic decisions. Planners increasingly recognized that air superiority was becoming untenable to maintain through conventional fighter aircraft. This recognition contributed to the Japanese decision to invest heavily in suicide aircraft programs. The recognition that conventional air combat was being lost to American material advantages, and that the only way to achieve tactical effect with dwindling aircraft and pilot resources was to fundamentally change the nature of air combat by accepting death as an inherent part of the operational design. The Corsair also influenced Japanese thinking about future aircraft development. The recognition that Japanese industry could not match American production capacity or American technological sophistication in conventional fighters contributed to the Japanese decision to pursue exotic designs, rocket-powered interceptors, ramjet-powered aircraft, and other experimental configurations that represented attempts to leapfrog American conventional designs through radical innovation. These programs largely remained experimental because Japanese industry, already strained to its limits, could not allocate the resources required for such development, while simultaneously trying to maintain production of conventional aircraft and other weapon systems. Japanese military historians, in retrospective analyses written after the war, frequently cited the examination of the captured Corsair as a turning point in Japanese understanding of the war's trajectory. The aircraft had become more than simply an enemy fighter. It had become a symbol of the fundamental disparity in resources and industrial capacity between Japan and the United States. The detailed technical understanding that Japanese engineers had developed through their examination of the Corsair removed any lingering doubt that Japanese air superiority could be re-established through improved aircraft design or improved pilot training. The advantages were material, systemic, and insurmountable. The symbolic weight of the Corsair's abundant fuel capacity, that 237 gallons of internal fuel, plus another 165 gallons in drop tanks, began to represent for Japanese planners something much larger than mere fuel reserves. It represented an entire philosophy of warfare that assumed that battles would be fought across vast distances, that aircraft would need to transit hundreds of miles to reach combat zones, and then more hundreds of miles to return. That American strategy assumed continental-scale operations where logistical support could be maintained across entire ocean basins. The Zero, by contrast, had been designed for the types of campaigns that had characterized Japanese military operations: rapid strikes from island bases against nearby enemies, short-range operations in well-established territories. The Corsair's design represented a different vision of warfare entirely, one where technological capacity enabled warfare at unprecedented scales and distances. For American pilots, the Corsair had become a revelation of different sort. They discovered through combat experience what Japanese designers had believed, that the aircraft could absorb punishment, could return to base on one engine, could survive hits that would have destroyed other fighters. The armoring that Japanese engineers examined with such fascination had proven itself repeatedly in combat, saving pilots' lives and allowing aircraft to return for further operations. American pilots also discovered that the Corsair could dictate terms of engagement through superior climb and speed, that they were not forced to accept the fight in the Zero's preferred environment of tight, slow-speed maneuvering. American pilots learned to use the Corsair's performance envelope to their advantage, climbing for altitude, using speed to separate from engagements, and attacking from superior tactical positions. The Corsair also became symbolic in a different way for American war production. Here was an aircraft that represented not the genius of any individual designer, but rather the collaborative product of American industrial organization. Vought designers had created the configuration, but Pratt and Whitney had built the engine. Goodyear had supplied the tires. Hamilton Standard had manufactured the propeller, and dozens of other companies had contributed components and systems. The aircraft that emerged was the product of an entire industrial ecosystem working toward a common objective. This was American strength, not the brilliance of individual innovators, but the capacity to organize entire industries around complex objectives and to maintain that organization at scale over years. As 1944 progressed into 1945, and as Japanese forces found themselves pushed back across every theater, the shadow of that captured Corsair loomed over Japanese strategic calculations. The aircraft had become a physical reminder of what Japanese planners now understood in their bones: that the war in the Pacific was not going to be decided by courage or by dedication or by warrior spirit. It was going to be decided by factories and production lines, by access to resources and industrial capacity, by the ability to design and manufacture weapon systems at a scale that the opponent simply could not match. The Corsair represented not just a superior fighter aircraft, but something far more profound, evidence of a fundamentally different approach to warfare, backed by fundamentally different resources and fundamentally different industrial capacity. It represented American abundance and American confidence in material advantage. It represented the belief that problems could be solved through application of resources and industrial organization. And it represented the material reality that was coming to dominate the Pacific War. That American industrial capacity, combined with American strategic resources, created advantages that Japanese military planning could acknowledge but not overcome. The epilogue to the story of the captured Corsair is written in the history of the Pacific War's final years. Japanese aviation, unable to match American aircraft performance through conventional design, increasingly abandoned conventional air warfare in favor of desperate tactics. Suicide aircraft programs represented the ultimate expression of the recognition that conventional air superiority was no longer achievable. The warrior spirit that Japanese military culture had valued so highly could not compensate for the material advantages that American industry provided. By 1945, Japanese aircraft were being operated by inexperienced pilots with limited fuel for training, flying machines that were often inferior to American designs, facing American pilots who had extensive combat experience and who were equipped with aircraft that could absorb punishment and still fight. The F4U Corsair, that single damaged aircraft that had crash-landed on Bougainville in June 1943, had revealed a fundamental truth about modern warfare, that battles were not decided by the courage of individuals or the refinement of design philosophy or the spiritual commitment of warriors. Battles were decided by the ability to manufacture weapon systems reliably and at scale. They were decided by access to resources and by the capacity to organize industrial production around military objectives. They were decided by the ability to sustain campaigns across vast distances and vast periods of time and to replace losses faster than the opponent could inflict them. The Corsair was ultimately a machine of abundant resources, abundant horsepower from its massive engine, abundant armor protecting its pilot, abundant fuel for sustained operations, abundant ammunition from its 6 machine guns. It represented the philosophy of a nation that could afford to be generous with its resources, that could design and build weapon systems without the constraints of scarcity that dominated Japanese planning. And in that abundance lay the ultimate answer to the question that had driven Japanese military strategy. Could warrior spirit overcome material disadvantage? The Corsair suggested the answer in its every component, in its robust construction, in its powerful engine, in its ability to absorb punishment and continue fighting. The answer was no. Material advantage, rooted in industrial organization and resource access, had become the decisive factor in modern warfare. That captured Corsair slowly dissected by Japanese engineers as they confronted the implications of what they were examining, became a symbol of the future that was coming. A future where warfare would be decided not in the sky through individual combat, but on the factory floor through production rates and industrial organization. A future where the warrior traditions that Japanese military culture had valued for centuries would become secondary to the ability to manufacture weapon systems reliably and at unprecedented scale. The Corsair represented not just American military capability, but American modernity itself, organized, systematic, abundant, and ultimately overwhelming in its material superiority. As Japanese prisoners of war reflected on their experiences in the final years of the war, many would speak of the moment when they first understood that Japan could not win. For some, that moment came through arithmetic, reading casualty reports and understanding that pilot losses were exceeding pilot training capacity. For others, it came through experience, facing American aircraft and American pilots with increasing frequency and with increasing disadvantage. But for many in the technical and aviation communities, that moment of understanding came through the examination of that single captured Corsair. Here, in physical form, was the evidence that the war could not be won through conventional means. Here was the material manifestation of American industrial capacity and American strategic confidence. Here was the future, and it belonged to a nation with resources and organization that Japan could never match. The legacy of that captured F4U Corsair extends beyond the specific historical moment of its examination. It became part of the historical record of how modern warfare is decided, not through the brilliance of individual designs, but through the capacity to organize entire industries toward military production at unprecedented scale. It became part of the larger history of the Pacific War, a war that would ultimately be decided not by the tactics of individual pilots or the courage of individual soldiers, but by the differential in industrial organization and resource access between two very different societies engaged in total war. The Corsair represented freedom of a kind that extended beyond political ideology into the material realm. It represented the freedom to design without scarcity, to build without constraint, to pursue objectives through the application of abundant resources. And that material freedom, that abundance that Japanese engineers confronted when they examined that damaged aircraft, ultimately proved more decisive than any other factor in determining the outcome of the war in the Pacific